All right. Good morning, everyone. Let's start class. All right. Last class we talked about what is a time series, right? We say any data is collected over time, that will be a time series, right? So we say it can be collected over yearly, monthly, daily, weekly, quarterly, every 2 minutes, every 10 minutes, every 15 seconds, something like that will be all considered as a time series, right? And then we say once we have a time series, we want to describe it with these four components, right? So we have the trend component. We look at the overall pattern. It is getting increasing, decreasing, or keep the same, right? So if it is keep the same, we call it is stationary, right? That means no trend, right? And then we say for the second component, seasonal component, we look for small repeating pattern that's within the year, right? So actually we look for the repeated pattern within years. That means the period is less equals to 1 year, right? Then that means this time series has a seasonal component, right? So we do not look for exactly the same pattern, but at least it should be roughly stable over time, right? Okay, and then next component, we talked about the cyclical component, right? We still look for the repeating pattern, but now this pattern should be bigger pattern that will be repeated every 2 years, 5 years, right? That will be over 1 year. Right. Then this kind of repeated pattern, we call this time series has a cyclical component. Right. And then the last one, the irregular component will take care of, for example, this time series has a random fluctuation, has a lot of jumpings, right? And or any outliers spikes, right? Then that means this time series has the irregular component. All right. And then we say once we get some idea about the time series, we know whether this time series has a trend component or a seasonal component or no trend, no seasonal component. Then we can decide which method we can use to make the prediction, right? So we say if a time series has a trend component or a seasonal component, that means they have stable relationship, right, between the time and the response variable y. Then we can use our modeling methods, right? So then once we use the modeling method, we can set up this kind of stable relationship, right? And then with this stable relationship, we can make forecast or prediction about a further future, right? Not only just a one time period or a one time point. We can do the prediction for a further future, right? And then we say if a time series doesn't have the trend component, doesn't have the seasonal component, it is just a random time series, right? Then the smoothing method will be preferred, right? Because the modeling method cannot take care of this case, right? Then we say if you use the smoothing method, then you can only make the forecast for the very near future, right? Usually just a one time period or just a one time point, right? And it is also very sensitive to the outliers, but there's no other ways, right? And we cannot use the modeling method. Then this is the only way we can use, all right? And then last class we talked about the smoothing methods, right? So actually once we have a time series and then we want to smooth this time series, follow the overall trend, right? And then based on this time series, we can use the trend to make the prediction about the next time point, right? And then about how to smooth this curve, we actually talked about the first method, which is the simple moving average method, right? We short for MA. right? And then for the simple moving average method, we generally first we need to identify the L, right? We need to define a L, which is the length of the average, right? And then we say, for example, if the MA 5, that means the L equals to 5, right? Then that means if I want to make the or calculate the estimated value of y, then I need to start with this point and then until I get 5 of them, right? And then that means not available for this point, not available for this point, not this point, because you cannot get 5 of them, 5 previous data points, right? And then for the next estimated value, we need to switch, which is the moving the average to the next 5 of them, right? So we start from this point and then go up until you get 5 of them, right? So get switched 5 data points, and then you just get average of these 5 points to get, we call these are the estimated value, right? We use the y of t with this sign. All right, and then we call this is the estimated value, but actually we want to make the prediction, right? So then how to make the prediction? We say the predicted value of this data point will be just equals to the previous estimated value. Right, so actually our point is to first get the estimated value of y, and then based on the estimated value of y, we kind of get switched, right? So switch to the next one so that we get the predicted value. So actually it's predicted value for the next time point. All right, okay, so that will be the simple moving average. And then we say, since for these two, right, one is L equals to 5, the other one L equals to 15, right? So one is averaging every 5 points, the other one is averaging every 15 of them. So which one is smoother? 15 will be smoother, right? So then based on this plot, so that means the blue one will be L equals to 15, right? The yellow one, which is less smooth, that will be L equals to 5. All right. Okay, so that will be the simple moving average. And then in the last class we talked about the problem with the simple moving average, right? We say for the simple moving average, we just average of every, for this example, every 5 of them, right? So if you get the estimated value of 7, that means you start with 23 until you get 5 of them. You just average of these 5 data points. That means every data point weighs the same in your prediction, right? If L equals to 5, that means everyone takes 20% of the weight, right? But actually in our real life, in most of cases, actually the recent value should be more important than the other previous values, right? Because they have the similar conditions with the next year or next week, right? So actually we say why we call the simple moving average is a naive forecast method. Is actually in our real life, they should have different weight for our recent value and the historical values, right? They should have different weight. The recent values, in most of cases, they should have the uh, the more important role in our prediction, right? And then we have the advanced weighted moving average methods, right? So we just assign different weight to these data points, right? Of course, there are different ways to assign the weights, right? Here we just focus on this method, right? The exponential smoothing method will be very commonly used weighted moving average, right? So now let's see how we assign the weights to different data points. right? So we say for the exponential smoothing method, we, instead of the L, we set the alpha, right? So what is alpha? We set alpha as the weight for the recent value, right? So what is the recent value? That would be our observed value, right? For this data point, what you observed, right? So that will be our most recent value for the next point, right? And then we say we set the weight for the recent value as alpha. Then the other weights, 1 minus alpha, will be the weight for all previous values, right? We also call it is the historical values, right? So we say we set the alpha, which is the weight for the recent value, and 1 minus alpha as the weight for all the previous values, right? Then we can calculate the estimated value by what? By two parts, right? The first part is the weight times the current value or the recent value, right? So that will be for our recent value. Right? The weight times the value of it, right? And then next will be the weight, which is 1 minus alpha for the historical values, and then you times the previous estimated value. So that will be for all previous estimated, all the previous historical values. All right, and then we say in this case, we have three cases, right? So when we say alpha equals to 0.5, that means the recent value has the same weight with all previous values, right? So that means every data point has the same weight for your prediction, right? So that means alpha equals to 0.5 will be just a change to simple moving average, right? Everyone have the same weight. And now next, when alpha is close to 1, that means what? That means the weight assigned to the recent value is larger, right? So that means the recent value is more important in your prediction. Then your prediction will be very close to your recent value, will be very close to what you observed. Your prediction should be just very close to your observations, right? And then the other way, we say if alpha is close to 0, less than 0.5, right? That means what? That means the weight we assign to current value or recent value is actually smaller than the weight for the historical value. That means the recent value is not that important, right? All the previous values will be more important, right? Then that means your prediction will be based on your previous values, right? Then it will be more smoothed and a little bit far away from what you observed, right? So then in this case, we say, again, if you are given with these two curves, smoothed curves, right? So which one is which? Which one is 0.75? Which one is 0.1? We say for the first one, alpha equals to 0.75. That means the recent value is more important, right? That means your prediction will be more close to your recent value, which is your observed value, right? So that means which one is more closer to your observed value? The purple one, right? And then the other way, alpha equals to 0.1, that means all the previous values are more important. That means it will be based on all previous values, right? So you have a lot of points for the previous values, then it will be a little bit far away with your observed values, right? It will be more smoothed, will be the yellow curve. All right, okay. And then we are done with all theoretical things. right, about the exponential moving average. Right now is our time to practice or calculate this estimated value by ourselves, right? So we say we actually want to get the estimated value of t, estimated value of y at the time t, right? And then we say we have the formula for the estimated value of y, right? We say for the time t, a equals to alpha times the current value plus 1 minus alpha times the previous estimated value. All right, okay, now let's say, let me show you how to do this. All right, so first we say for the first week, by the formula, we have the current value, which is the recent value is this 17, right? But do we have the previous estimated value? No, right? So in this case, as a starting point, we just use its original observed value as your starting point, right? So we just use the 17 as the first week estimated value. Right, so this is a starting point. Right now, for week 2, now we have our current value or recent value, which is 23, and then we have the previous estimated value now, right, which is this 17. Right now, we can plug in these values. We say the estimated value for week 2 will equals to alpha, right? So we know the alpha is given, which is 0.75. Right? And then times y of t. So what is y of t? What you observed, right? So yt will be how many calls you got from the record, right? So it will be 0.75 times 23, and then plus 1 minus alpha, 1 minus 0.75. Right now times the previous estimated value, which is 17, right? The previous estimated value, which is 17 as the starting point. All right, then based on this, you can calculate it as 21.5. Right, so now this is 21.5 for the estimated value for week 2. Continue. Let's calculate the estimated value for week 3. Again, by the formula, right, it will be equals to alpha 0.75 times the current value. So what is the current value now? What is the recent value for week 3? 25, right? Thank you. All right, so it will be 25 will be the current value for week 3 now, right? Plus 1 minus alpha, 1 minus 0.75. All right, now times what? Times 23 or 21.5. Anyone?
21.5.
21.5, right? Thank you, Nico. Right, so it would be 21.5 because we need to times the previous estimated value, right? So we need to use the previous estimated value. So now it actually equals to 24.125. All right, so now you can think about the whole process. Actually, this 21.5 takes care of the first one, right? And then actually for week 3, you take care of both of these two cases, right? So that will be all previous values, right? So now you have the week 3 estimated value, which is 24.125. All right, continue. About estimated value for number week 4. Anyone want to try? Let me see. Um, okay. Joe, are you there?
Yeah.
Okay, you want to try? The estimated value for week 4. Joe,
Yeah.
so you want to try how to calculate this estimated value?
Yeah. I'm working on it right now.
You can just show me the equation, right?
Is it 0.75 times 22
Perfect. Continue.
plus 1 minus 0.75 times 24.125?
Perfect. Good job. All right, so now it equals to 22.53. Right, so now we get the estimated value for week 4, which is 22.53, right? And then the last one, right? So we have the last one, the estimated value for week 5 will be alpha, right? 0.75 times the current value, which is 19, plus 1 minus alpha, which is 0.25, times the previous estimated value, which is 22.53, right? So after calculation, you should have this 19.88, right? Got the idea? Right, so actually now think about the difference between the simple moving average and the exponential moving average methods. We say both of these two are to smooth the curve, right? Both of these two methods are called the smoothing methods, right? Simple moving average is actually we just average the, for example, the average 5 data points depending on the L, right? And then we actually assign the same weight for each data point, right? Is here, right? So actually, for example, if I want to get the estimated value for week 6, then I just start with week 6 until I get 5 of them in the back. All right, and then that will be the estimated value, right? So actually, for the simple moving average, you can just directly come to this point and then just the average of these 5, right? So actually, we do not need to start from the first point, right? But for the exponential moving average method, actually every estimated value is depending on the previous one, right? So actually for the exponential moving average method, you need to start from the first point, right? You need to start with the first week until you need to keep calculating the estimated value until the last one. All right, okay, and then the same thing. Once we have this estimated value, what are the predicted value? The same thing, right? It will be the same step. We say for the predicted value, we use the y hat, right? And then we say to make the prediction for week 1, well, actually, we need to use the estimated value for week 0, but we do not have that, right? So actually not available for week 1, right? And then for week 2, to make the prediction for week 2, we actually use the previous estimated value, right? So then again, the predicted value for week 2 will be just 17, right? Similarly, we say the predicted value for week 3 will be the estimated value for week 2, right? So it will be 21.5. We just use the previous estimated value as your predicted value, right? So everyone gets switched, right? It's 24.125. Next one, 22.53 for week 5. And then last one, we have what? We have for 6 week, right? So for week 6, for the prediction, which is 19.88. All right, so that will be the way how you get the prediction based on the exponential moving average method, right? So again, the whole point is depending on your estimated value, right? So once you have the estimated value, the predicted value will be just get switched from the previous one. All right. Okay, and then we say once we have the prediction, right? Whenever we have the prediction, we always want to know how accurate is our prediction, right? We always want to calculate our residual, the distance between what you observed and what you predicted. Right, so actually we say to summarize the our prediction or forecast error or residual, right? We just use the residual here, right? It's again what you observed minus what you predicted. All right, and then we say in the regression, we usually use the MSE, right, to summarize all the residuals for every observation, right? So actually we say for each observation, we calculate the residual or the error, and then we square it, right? And then we say this is for each observation, and then we sum of all the squared error term divide by how many of them, then we get the mean squared error, right? So actually we squared the residual and then sum of all the residuals you have divide by how many of them, right? So we have the MSE, right? But actually for MSE, there is a problem with it, right? We say if your residual is 2, right, no big problem. Once you square it, it's just a change to 4, right? But if your residual is 200, once you square this residual, it will be 40,000, right? So actually, this MSE kind of penalize the larger errors, right? Because once you square the larger errors, it becomes very large values, right? Then in this case, I want to avoid this kind of problem. Then there is another way to measure the residual. We call it is the mean absolute deviation, right? So actually it's still we get the residual for each observation and then we take the absolute value instead of the squared. Right? Then we do not have the penalty for the large errors, right? And then we sum up all of these absolute errors or absolute residuals, then divide by how many of them, right? Then we have the mean absolute deviation, we short for MAD. All right, so until here, for MAD, it solves the penalty problem. But actually for this measurement, there is another problem is we say if your Y, your response variable is measured with the centimeters, right? But actually they have the same length, but I measure it with the millimeters. Then the error or the residual will change from 2 centimeters to 20 millimeters, right? So actually they have the scale problem, right? The rescale problem, right? So now how we can deal with this so that I can know that this kind of measurement of the error or the residual is no relationship with the units. Right, then here we'll introduce another one, which is the most commonly used way to measure the residuals, right? So we call it is the mean absolute percentage error, right? Short for MAPE. Right, so what is that? We say since we want to take the absolute value of the residual in the MAD, right? Then what if I divide by what you observed? So that I have a proportion or percentage, right? So now the unit in the top will be canceled with the unit in the bottom, right? And then they have no relationship with the unit. The units will be canceled out. All right. Then in this case, we say for each term, for each observation, we find the observed value of y minus what you predicted. Take the absolute value to make it positive, right? And then divide by what you observed, right, for each observation. Right, so then you sum of all of these terms together, divide by n, that will be a proportion, right? And then times 100 will be the percentage, right? So then we call this is the MAPE, M-A-P-E. All right, okay, then actually this MAPE can solve all of these problems, right? So remember in the chapter 19 when we talk about the validation MSE, right? So remember that in the two tables when we compare model 1 and model 2. Model 1 is the original one, model 2 with the transform one, the natural log transform one. We say we cannot compare the MSE because they have different units, right? That will be because of that. But if you use the MAPE, there will be no problem. You can just compare these two models. All right, okay. So here we say, let's just focus on our time series, right? So we say, again, we have this this time series, short time series, right? So we say in the last step, we have already got our estimated value of y. Right, by the exponential weighting average, weighting moving average, right? So with alpha equals to 0.75. So we have estimated value of y. The first one keep the same, 17. Right, next one we calculate it as 21.5. Next one we calculate it as 24.125. Next one is 22.53. Next one is 19.88. Right, so remember they are calculated by our exponential method, right? So we use this formula to calculate these values. All right, and then we say we also have, based on the estimated value, we also have their predicted value, right? So actually we can have one more row for their predicted value, y hat. All right, okay, and then we say, okay, so since there is no available previous estimated value for week 1, right? So not available prediction for week 1. And then for week 2, we use the previous estimated value, right? So it would be 17, right? And then for week 3, the predicted value for week 3 will be the estimated value for week 2, right? So it would be 21.5, and keep switching. You have 24.125. Next one will be 22.53, and then next you have the predicted value for 6. Right? Okay, and now think about how we can calculate our MAPE. I say we have the formula, right? MAPE equals to 1 over n, 100, right, times 1 over n times summation of each observed value minus the predicted value divided by the observed value. Right? Okay, so actually the first thing is you need to find this term for every observation. right? So now think about week 1. What is the YT? What is the observed value? It will be 17, right? And then the predicted value not available, right? So that means what? That means for week 1, we do not have this term, right? Then for next week, week 2, what is the observed value? 23, right? What is the predicted value? 17, right? So actually, week 2, we have one pair of YT and YT hat, right? So then we say for the week 2, we have 23 minus the predicted value 17 divided by what you observed, 23, right? So this is for week 2. Right? And then continue for the next week. We have the observed value 25. We have the predicted value 21.5. Right? So then we have what? We have the observed minus the predicted divided by what you observed. Right? So we say this is for week 3. Right? Okay, and then continue. We say for week 4, we have the observed value 22 minus the predicted value, right? 24.125 absolute value to make it positive, right? And then divide by 22, right? And then next one, week 5, we have the observed value, which is 19 minus what you predicted, 22.53, right? Divide by what you observed, which is 19. Right, so here actually we make the absolute value. That means we want every term to be positive, right? So now think about week 6. Do you have this term? We have the predicted value, right? But we do not have observed value, right? So actually you do not have this pair of values, right? So in this case, that means for week 1 and week 6, you do not have this pair, right? You only have 2, 3, 4, 5. So actually how many pairs you have? You have 1 term, 2 terms, 3 terms, and 4 terms, right? So now we need to sum of all of these terms together and then divide by times 1 over n. That means divide by how many of them, right? So actually we have 4 pairs, so that will be 1 over 4, and then times 100 to change it to a percentage. All right, so that will be our MAPE. Got the idea? Right, so then after calculation, you have 100 times 1 over 4, and then times 0.6833, so that you have 17.0825. So that will be your MAPE. So normally what we do is once we have this kind of time series, we want to try both of these two methods, right? Simple moving average method and also the exponential method. And if you learn other methods to assign the weights, right, we just keep trying different ways and then we calculate the MAPE until we get a very small MAPE, and then we think, okay, this weight will works best, right? Then we will use this way to make the predictions. All right, so here we just show you how to calculate the MAPE for this example. All right, so I think that will be it for today. I want to leave the regression part for the next week, right? So now I will give you time to complete your essay assignment 7 so that you have the time to talk with your team members during the weekend to talk about your project 2, right? So just work on the essay assignment and then let me know if you have any questions. Right, and again, for your exam 2, all right, so if you saw my announcement, right, the average is still 78, all right, and your um, median is, I think, is 82, right? So since for this example, I provided 3 points extra credit, the total of this exam is actually 103, right? But your grade is still calculated based on the 100 schedule, the scale, right? So you don't need to worry about if I get uh, if I get 80, right? Does that mean that I get less than 80? No, you still be scaled with the 100 scale, right? But I really want to congratulations to the 2 students who got the full points, 103, right? Really good. All right, and based on the summary, right, which is the histogram summary or the other summaries I showed in the announcement, right, just try to look at that and see where you are, right? If you think you fall behind, you really need to work harder. All right, okay. Now, again, all right, if you want to review your exam with me, all right, just feel free to make a schedule meeting with me. All right, I will be available most of the time this weekend, next Monday, and next Tuesday. Right, so we still have next Tuesday's office hour, right? And also office hour on Thursday, right? So anytime you feel you're available, just email me and check whether we can meet on the WebEx, right? So then I can share my screen with you and then we can work on each problem that you missed. All right, okay, so now is your time to complete the essay assignment 7. All right, if you have any questions during when you have the calculation, just let me know. All right, so here I will still share my screen. So first you will have the simple moving average. Right, so actually you have this time series, right? And then based on this time series, right, you need to use 4-point moving average. That means what? That means your L equals to 5, right? So that means the first point you get or first estimated value will be for 2020, right? That means all previous ones will be not available. And then next one will be these 4, right? Okay. Right. Just unmute yourself if you have any questions, right? And I will not talk about this assignment once you submit, right? I will just grade them and I will not just review the essay assignment after maybe next week, right? I will not talk about that again. So if you have any questions during your calculations, just let me know. And again, your project 2 is due next week, right? So if you haven't started yet, you need to be in rush, right? So you have a lot to do and you need to make a lot of discussions with your team members. You have a lot to write out, right? So start as soon as possible. If you have any personal questions, you can just type in your question in the chat, right? No problem. I'm watching. Any questions? No questions? All going well? Okay. Just for check, right? For the question A, for the simple moving average method, right? How many predicted value do you have? How many predicted values do you have for simple moving average method? Anyone? How many do you have?
Is it just one?
Just the, predicted value.
Would you want 3?
Will be 3. Let's look at the Let's look at this question, right? So actually for the simple moving average method, that means L, in this case, L equals to 4, right? It is 4-point moving average. That means the first one you have is just these 4, right? So actually you have 1 here, right? 1 for estimated value for 2020, right? And then for 2021, you have another one here, right? And then when you make the prediction, that means do you have the prediction for 2017? No, right? Because you don't have the previous estimated value, right? And then for 2018, again, not available. 2019, not available because you don't have the previous 2018 estimated value, right? And then for 2020, also no estimated value, right? Then for 2021, you have one estimated value for 2020, right? So that means for the 2021, you have the predicted value. And then you have actually one more predicted value for 2022 because what? Because you have the estimated value for 2021, right? So actually for the 4-point moving average method here, you have actually 2 predicted value, one for 2021, one for 2022, right? But in this table, you only have one, right? So that is why I have another question for asking about the predicted value for 2022.